Okay, so we were discussing about the common mechanical forces last time, and we have seen about normal reaction and tension. Yeah, Hitanshu, the two batches are merged, so now it is foundation batch. Okay, foundation builder batch. Yes, so coming back to this, we were discussing about the common mechanical forces last time, and we had seen about the force called tension or tensile force. Okay, that is the force that is developed in a thread or chain or rope or any such longitudinal material when it is pulled from both the ends. Okay, so towards the end what we had discussed is that for a light thread, light, or sometimes we call it massless, that means basically that mass being very small for that particular chain or rope. So for a light, or what we can say massless, that is mass being negligible. Okay, so for a light thread or string, the magnitude of tension is always uniform throughout. So this is what we had discussed about last time. So we will continue with a couple of questions based on that first. Okay. So now, for example, if we have a situation like this, on a smooth frictionless surface, a block of mass m is placed like this. Now this is a light thread, and what is happening is that we are pulling this with some external force F. So in this case, let us say, given a block of mass 10 kilograms attached to a light thread, is pulled horizontally with the application of force F equal to, let us say, 5 newtons at the end of the thread, as shown. So what we have to first do is find the tension in the thread, and secondly, make a free body diagram of the block and show all forces acting on it. Okay. And from that, find the block's acceleration. Okay, so just work out this question. Yes, Rishi, I will come to the discussion of the assignment. That will be the second half of the lecture. Let's discuss few more applications of these concepts first. Okay, so can you tell me the answer of the first part immediately? The tension in the thread will be how much in this case? Yes, that is correct, Rishi. No, Om, that is not correct. Okay, that is the weight of the block. Okay, so that will not be the tension in the thread. Yes, Hitanshu, correct. So F is given to you, na? So it will be that much only. So see, let's understand one thing. What is the principle? What is the concept we apply to find out the tension in the thread? Okay. It is nothing but Newton's third law. देखो end of the thread पे मैंने जो भी force apply किया as an external agent, think of that as an action. Okay. So obviously as an external agent, I'm pulling the thread with some force F. So the thread will pull me back with an equal and opposite force, and that is nothing but the tension. But that becomes uniform throughout the spring because it's a massless spring. So first of all, here you apply action reaction principle. You apply the principle of action reaction at the end of the thread. So you see the magnitude of tension has to be equal to the amount of force we are applying, which is given to be 5 newtons. Okay. So now it's a massless or light thread. Okay. So therefore it has uniform tension. So same tension at both the ends. Okay. Throughout the string. So that is the answer to the first part. Okay. Then you make the blocks free body diagram, of course. Okay. And in that you understand that on the block, okay. So ideally when you make a free body diagram, you should represent it by a point mass, okay, and show all the forces acting on it as vector arrows. So there is tension, there is normal reaction that the ground is applying, and there is weight. Okay. So tension, normal reaction, weight. And under the action of all these forces, the acceleration of the block is along this direction. So hence what you do is you take the horizontal as your x-axis, the vertical as your y-axis. Okay. So T is along the x-axis, we have T is equal to ma. So 5 newtons is equal to 10 kilograms into A. So the acceleration is 0.5 meters per second square. So that becomes your third part's answer. And along your y-axis, N minus mg should be 0. So the normal reaction force that the ground is applying has a magnitude equal to 100 newtons, which is the weight of the block. Taking G as 10, of course, assuming G is 10 meters per second square. So this is normal reaction. This is the tension of the thread which is acting at this end of the block, and this is of course weight. So only three forces acting on the block. So hope this question is clear to all of you people. So now let us see slightly more interesting examples of tension. So we have a combination of two blocks which are vertically hung. Acha. Okay, we'll come back to this. I wish you can finish writing this down first. Okay. Yes, in the last lecture, Hitanshu, we have, in fact, last couple of lectures, we discussed about normal reaction, whereas in last lecture in particular, we discussed about both normal reaction and also tension. Okay. So both of these are light threads. This is also a light thread, whereas these are blocks. Okay. And again, we have to take G as 10 meters per second square. So given that blocks A and B are of mass equal to 10 kilograms and 20 kilograms. Okay. Find the tensions in each of the threads. Okay. Assume the threads do not break under the tension. From the weight of the blocks. Okay. So you assume that the strings are or the threads are strong enough to withstand the amount of tension required. So which string has that much? The upper string or the lower string? Upper. Yeah, that is correct, Om. And the lower one, Hitanshu, tension. Yeah, that's correct. Good. Om, that's correct. Now, Hitanshu, tension should not be expressed in unit of mass. It should be expressed in unit of force. Okay, remember, tension is a type of force. So whatever answer you are giving for tension, it should be in newtons. Yes. Okay, so suppose what I do here is I take the tension in the upper string as T1. Now throughout the string it will be uniform. Okay, and I take the tension in the lower string as T2. So throughout the string it will be uniform. Now the answer to everything in Newton's laws is about free body diagram. If you got the free body diagram correct, you cannot go wrong in your analysis. Okay. So see what is happening when I look at the free body diagrams. For A, the free body diagram is like this. There is weight which is 100 newtons. Okay. There is some tension, sorry, T1 in the upper string, which I don't know how much it is. And there is also tension T2 pulling it downwards, and its acceleration is zero because it is at rest. Okay. So for the block A, I have the equation that T1 is balancing T2 plus me. Okay. Or I have T1 minus T2 is equal to 100. So this is the first equation I have. But in this T1 and T2 are unknown. So I need one more equation. So where that second equation will come from? It will come from FBD of B. Okay. So for the block B, you can see the FBD is a little bit simpler because इस पे एक ही टेंशन ऐड कर रहा है T2 upwards, no other string is attached to it, and its own weight equal to 200 newtons acting downwards. And this one is also at rest. So we have T2 is balancing the weight of B. So we have T2 is equal to 200. So that's your equation 2. And now from these two, you can see that if you just add the equations, you get T1 is equal to 300 newtons. Okay. And T2 is already a what? 200 newtons. So the upper string has a tension of 300 newtons. The lower string has a tension of 200 newtons. Which makes sense also. No? The upper string will have more tension because two blocks are hung under it's withstanding the weight of two blocks. As the lower string is withstanding the weight of only one block. So its tension is only equal to the weight of B. Okay. So this kind of logical method of calculating forces, acceleration, etc., whatever required. Here there is no acceleration, but in any question where there's acceleration. So this kind of logical method is very important. Okay. The logical method being free body diagram. Everything in Newton's laws and even the next chapter, friction, when we come to that, is about solving the free body diagram correctly. Okay, so next question for you people. Now try to get this one correct, all of you. Okay, so all this you have to find. So you have a combination of two blocks and you are pulling from either end at using forces F1 and F2, which are at angles alpha and beta like this. Alpha is 37, beta is 53 degrees. So you see that one of the forces will dominate in the horizontal direction, and as a result of that, the system will accelerate. Okay? Because they are connected by a thread, so A and B will accelerate together. They will have a common magnitude of acceleration. So, so using the free body diagrams, you have to calculate all these three things. Okay, so try out this question quickly, people. No, smooth surface is known as frictionless surface, beta. ना smooth surface का मतलब क्या होता है? When there is no friction. So another term for smooth floor is that it is frictionless surface. Okay. Whereas when it's a rough surface, there will be friction, and we will come to that in the next chapter. Okay, so any students from Greenhouse who have just entered because of the link sent to you by administrative staff, please log out. This is a scheduling mismatch. This lecture is not Greenhouse lecture. This is a foundation builder lecture. Greenhouse doesn't have a lecture today. You have already been informed by Ganeshwar sir about that. Okay. So students from Greenhouse, you can please log out of this lecture. You will have your lecture with me next week for laws of motion. Okay. There's some confusion on part of admin staff, Devansh. Okay, so yeah, sorry about the confusion, students. If anybody is present from Greenhouse over here, you this is not the session for you. This is for Foundation Builder batch. Okay, now let's come back to this question. So, who all have got the answers? Okay, so I will just verify the answers for you. So first of all, let us make the free body diagram of each of the blocks. So the one thing you can start with is the uniform tension, which will be acting like this. Okay. And the other thing is, because F1 is greater than F2 in magnitude, and also this angle is less, so we can assume that they are moving such that F1 is dominating. So the direction of acceleration is like this. Okay. So hope this is clear to all of you. The direction of acceleration. Okay. Okay. Now let's come to the free body diagrams. So B is free body diagram. So I'm just making them slightly bigger, but like this. We'll have F1 equal to 15 newtons acting like this at an angle of alpha equal to 37 degrees. Okay. We'll have some kind of normal reaction, let's say NB. We'll have its weight, which you can see is 10 newtons. Okay. And it will have tension acting like this and horizontal acceleration A like this. Okay. Whereas A is free body diagram, we'll have tension acting like this, some kind of force F2, which is, how much is it? 10 newtons acting like this at an angle of beta equal to 53 degrees. Normal reaction acting upwards, weight acting downwards, and horizontal acceleration A. Okay. So using all this, when you solve, you should be getting the acceleration A as, just give me a moment, I'll tell you. So you should be getting the acceleration as 2 meters per second square. Okay. And you should be getting the tension as, yeah, you should be getting the tension as 10 newtons. Okay. And you should be getting the normal reactions on A and B as the following. So this one's weight is 20. So this will become 12 newtons. Okay. A normal reaction on B, you should be getting as very less, 1 newton. Yeah. Okay, so let me work out the equations and tell you how this is coming. Okay, so actually there's one more step in between. You have to resolve the forces. So after resolving the forces, let's see how this will look like. So on resolving the forces, A का जो force diagram है, that will look like this. Okay, tension acting like this will be F2 sine beta, which will work out to be how much? 10 into sine 53. So that will be 8 newtons. Okay, and normal reaction acting upwards. This side there will be F2 cos beta, which will be 6 newtons. Okay, and there will be weight, which is 20 newtons, and the horizontal acceleration is A. So this is A's free body diagram after resolving the forces. Okay. So what are the equations you will get? You will get T minus F2 cos beta is mass of A into acceleration. That's the first equation you will get. And you will get Na plus F2 sine beta balances the weight of this. That is the second equation. Okay. So this equation will become T minus 8 is equal to 2A. Sorry, T minus 6. Mistake. T minus 6 newtons is equal to mass of this is 2. So 2A. And this equation will become normal reaction plus 8 is equal to 20. Okay. So keep in mind these two equations that we are getting. Equation 1, equation 2. Now similarly, you make the free body diagram of this one and resolve the forces. So there is tension, normal reaction, weight, which is 10 newtons. But on resolving this force, you have F1 cos alpha. So that will become how much? 12 newtons. And you have F2, sorry, F1 sin alpha. So that will become how much? 9. Okay. Because you can see that F1 cos alpha is 15 cos 37. That is 15 into 3 by 5. Sorry, 15 into 4 by 5. So that is 12. And this one. So 15 into 3 by 5. So that is 9. So this is how you do this all this calculation. Okay? And this also has the horizontal acceleration E. So now for this we have the equations. For B we have the equations. F1 cos alpha minus T is mass of B into acceleration. So this equation becomes 12 minus T is A because mass of A was 1 kg. Okay. So this becomes, let's say, my third equation, and we have NB plus F1 sin alpha is together balancing weight. So you have NB plus 9 is equal to 10. This is your fourth equation. Okay. So now what you do is you take these two equations, this and this. Okay. So T minus 6 is equal to 2A and 12 minus T is equal to E. So this is your first equation. And third equation. Okay. You add both of these and you will get 12 minus 6 is equal to 3. So that will give you your acceleration is 2 meters per second square. and then from equation 2 you'll get normal reaction on this one is 12 newtons, and from equation 4 you'll get normal reaction on this one is 1 newton. Okay. And then what you do is substitute this in equation 1, for example. So you will get T as 10 newtons. Equation 1 or equation 3, whichever you like. So you get this also. So all these answers will come by solving the equations correctly. Okay. So it is the same set of steps. Make the free body diagrams, resolve the forces, express Newton's second law in component form, and then solve the equations. Okay, same steps. Free body diagram, resolve forces, okay, and then apply net force is equal to mass into acceleration in component form. So these are the steps that you apply in all these questions for Newton's laws. Okay. So hope this method is clear to all of you, and make a note of this, please. Okay, so hope students, the solving part is clear for this. Hitanju, how to make the equations? See, we are just solving Newton's second law along the x-axis and y-axis respectively. ये x-axis है, ये y-axis है. तो x-axis के along क्या हो रहा है? Net force कितना है? T minus F2 cos beta. So that is mass into acceleration. But y-axis के along क्या हो रहा है? The forces are balancing each other. Okay. Same for this. This is the equation along the x-axis. This is the equation along the y-axis. अरे वो तो सॉल्व कर गया है ना बेटा, सब्स्टिट्यूट किया ना वैल्यूज. ये सारा आपको दिया हुआ था ना. F1 का मैग्नीट्यूड दिया हुआ था 15 न्यूटन्स, अल्फा का मैग्नीट्यूड दिया, अल्फा का वैल्यू दिया हुआ था, F2's value was given as 10 newtons. So on substituting all this, we have got the boxed equations, and rest is solving of linear equations, which I've explained to you here what we've done. See, here we have added these two equations. Equation 1 and 3 is added, so we get this. That's how we are getting this. Then we are directly solving equation 2. Equation 2 has only one unknown. Equation 4 has only one unknown. So this is what we are doing from these. And then we are substituting the value of a that we solved into one of these two equations. That is giving us this. So this is that same simultaneous equation solving which you've learned in class 9th in maths. There's nothing more in this. Okay, so all these values you are substituting and then solving the equations. Okay, so hope this is clear to all of you now. Okay, now next we will move on to pulley based systems. Okay, so we will move on to pulleys. Okay, and systems with pulleys, threads, and blocks. So generally when you will come across a question with a pulley in this chapter, the pulley will be shown to you as the side view like this. Okay, shown as something like this. Like a pulley attached to the ceiling. Okay. Or we could have a situation where we have a pulley like this attached to the corner of a table or something like that. So this is the side view of pulleys. Okay. Now the first thing we have to understand that in Newton's laws of motion chapter, okay, a standard pulley will be one will be such that it has a smooth surface. Okay, and by smooth again we mean frictionless. Okay, so in terms of pulley we say this is a smooth pulley. So I'll explain what this term means, but first note this down. And secondly, a standard pulley will be such that its mass is negligible. What we call massless pulley. Okay. And third, it will have a fixed axle. That means it is not rotating about the axle. Now, before you note all this down, let me explain what this means. So, to understand these terms, that it is smooth, it is non-rotating, let's look at the three-dimensional view of the pulley. So, the three-dimensional view of the pulley basically looks like this. If you ever flown a kite, you know that this kind of thing is called the manja, on which the string is wrapped around. Okay. So this kind of thing, and this is the axle of the pulley. Okay. So for example, we had this thing, the pulley was attached at the ceiling. So three-dimensionally, this would look something like this. That the axle of the pulley is attached like this to some ceiling. Okay. Or we had a pulley attached to the corner of a table like this. So three-dimensionally, this would look like this. It's attached to some surface like this. Okay. Now, what we mean by smooth pulley is that this surface of the pulley is frictionless or smooth. Okay. So that means any thread that is wound around this, it can slip freely. So this thread wound around the pulley can slip freely when pulled. That is the first thing. Okay, that is the meaning of frictionless. Okay, and fixed axle. Okay, so that basically means that the pulley does not rotate about the axle. Okay, the thread simply slips. On the surface. Okay. So this is the meaning of a frictionless or of a standard pulley in Newton's laws chapter. Okay. Later we will study in another chapter, in chapter rotational mechanics. Okay. We will see, we'll learn about what is called rotating pulleys. Okay. And there, the surface of the pulley will have friction, but not in this chapter. In this chapter, always, even when the question is not explicitly telling you that it's a smooth pulley with a fixed axle, you have to assume that it's a standard pulley. So as a standard pulley, it will have these properties, that it will be smooth, it will be massless, or its mass will be negligible, and it will be having a fixed axle, so it does not rotate. Okay, so I'm giving you time, just note down all this properly. No, pulley is the name of this kind of structure. इसको ही pulley बोलते हैं. This yo-yo kind of thing, this is called a pulley. It's basically two discs with a cylinder attached in between. This kind of structure, it is called a pulley. Or this kind of a system is called a pulley system. Any system that has, so this object is called the pulley. So in that sense, it is a noun and not a proper noun. It's not somebody's name. Yeah, pulley is used in machines, and Hitanshu, that is what we will understand in the next part of Newton's laws of motion. Different kind of mechanical systems which have pulleys. You might have observed pulleys on cranes, etc., or in various types of mechanical engineering structures. Okay, so let's understand simple situation with a pulley involved. So, for example, if we have this situation, so this pulley is attached to the corner like this. This is a smooth surface. Okay. Now we are using a light thread which goes around the pulley. So one end of the thread is attached to a block here, and the other end of the thread is attached to a block here. Let's say these are blocks A and B. So this is a light and also what we call inextensible thread. Okay. So inextensible means it does not stretch. Okay. That is the meaning of inextensible thread. And this is a smooth fixed pulley. So that means the surface of the pulley is smooth. So okay, and blocks A and B have masses, let's say 20 kg and 30 kg respectively, and take G as 10 meters per second square. So first of all, make free body diagrams for A and B. Okay. Calculate the accelerations for the blocks and the tension in the thread. So since it's a massless thread or a light thread, the tension will be uniform throughout. So we have to calculate these three things. Okay. So just take down the diagram and start with the free body diagrams. I'll explain. Okay, so let's understand how we'll approach this question. So first of all, we'll understand whatever tension is at the lower end of the thread, same amount of tension acts here also. Because it's a light thread, because the thread is light, okay, or of negligible mass, okay, tension T has uniform magnitude everywhere. Throughout the thread. That's one thing. Okay. And second thing, which is very important, the magnitude of acceleration of A and B will be the same. Again, why that is the case is because the thread is what we call inextensible, so it does not stretch. Okay. So that's the first point. And the second point is because the thread cannot stretch. Okay, so therefore A and B have magnitudes of, or you can say they have same magnitude of displacement. They have identical magnitudes of displacement. That means if the block B comes down by 1 centimeter, the block A has to shift towards the right by 1 centimeters. So it's like this, that after some time, now if the block B shifts down here by X, then this has to shift by X. Why? Because the total thread length has to remain constant. Okay, so they have to have identical magnitude of displacement. So that means they will have identical magnitudes of velocity, and that will mean that they will have identical magnitude of acceleration. Okay, so these are two very important points to understand. That one is the tension is same throughout, and the other is because the string does not stretch. So A and B have identical magnitudes of their motion along the horizontal direction and the vertical direction respectively. So in the amount of time that B comes down by a distance x, A has to move horizontally by the same distance x. So whatever velocity B has in the downward direction, A will have to have the same velocity in the horizontal direction, and therefore the accelerations have to be identical. Ayush, we will come to systems with more pulleys, etc. Okay, multiple pulley systems. Yes, partly it is correct that when we have multiple pulleys, then we require less effort to lift the same amount of load. Okay, and that is a very important concept in mechanics and later in mechanical engineering, system of pulleys. So yes, your point is correct. But right now let us concentrate on the working of this system. Then we will come to systems with two, three, four, even multiple pulleys. Even we'll see. So you'll see something very interesting. We can, for example, lift a load of, you know, 500 kgs using a force of just 10 newtons or something. Okay. But for that, we require a system with multiple pulleys. So that system is used in machines, in heavy engineering and machines, in structural systems, etc. It's always used. Yeah, second point, Ruxer, see, concentrate on the diagram that I've made on the right. अभी क्या हो रहा है देखो, thread का total length constant है ना. So if the block B comes down by a distance x, it has to pull A by the same distance x, correct? Because the thread is not stretching ना. ठीक है, so is this point clear बेटा? X for B in the downward direction has to be identical as x for A in the horizontal direction. Why? Because the thread length is constant. Is this point clear? ओके, सो अभी देखो, अगर दोनों का डिस्प्लेसमेंट सेम होगा इन मैग्नीट्यूड, देन dx by dt will also be same. If x1 is equal to x2, then differentiation of x1 will be equal to differentiation of x2. Now what is differentiation of x with respect to time? It is velocity. So if they have identical displacement, they must have identical velocity, because rate of change will be equal. ठीक है, understood this point बेटा? So then same for acceleration. Okay. So because they have same displacement, so they have same rate of change of displacement. That means they have same velocity. If they have same velocity, then rate of change of velocity will also be same. So acceleration will also be same. Yes, Kunj, that is correct. Very good. Your value of acceleration is correct. So very good. Now that we have understood this, let's come to the free body diagrams of the blocks. Okay, so next I'm making the free body diagrams below. So before I make the FBDs, let me just copy this diagram from above because we are going to make use of this. Okay. So now see, in this, what all forces are acting other than what I have shown already? Other than what I have shown, which is the tension, there is the weight of this block. Okay. There is the weight of this block, and there is normal reaction acting on it. Okay. So the free body diagrams will look like this. For A, there is horizontal force of tension, vertical force of normal reaction, vertical force of weight, okay, and it has some acceleration E. So we have N is equal to weight, and we have T is equal to mass into acceleration. Okay, and for B, a free body diagram is much simpler actually. It has only tension upwards and weight downwards, and the block has a downward acceleration. So our simple equation is net force should be downwards. So that should be equal to mass into acceleration. That is our third equation. So that's it. We have three unknown quantities and three equations. Okay. We have three unknowns: tension, normal reaction, and acceleration. And we have the three equations. Okay. So the masses I had given were 20 and 30. Okay. So let's make use of that. Okay. So mass of A was 20 kg. Mass of B was 30 kg. So this second equation will become like this, that T is equal to 20A. The third equation will become like this, that 30G minus T is equal to 30A. So now add these two equations. So you'll get 30G is equal to 20 plus 30E. So you can see A will become 3G by 5, which is nothing but 6 meters per second square. Because we'll take G as 10 meters per second square. So they will have the common magnitude of acceleration. Okay. Then substitute this in equation 2. So we'll get tension as 120 newtons. So that is your second thing. So acceleration has a magnitude of 6, tension is 120. That's it. And if you want, you can find out the normal reaction from this. The normal reaction will become 200 newtons. That was not really asked in the question, so not necessary. Yes, I will do assignment discussion, Hitanshu, don't worry. Okay, so let's look at one more question involving single pulley system. So this is a standard smooth fixed pulley. Okay. This is a massless and inextensible thread. Okay. Mass of E is given to us this time as, let us say, 6 kilograms. Mass of B is given to us as 4 kg, and we have to take G as 10 meters per second square. So make free body diagrams for A and B and calculate accelerations and tension in the thread. Okay. Work this out quickly, people. This should not take you too much time. Should be able to do this in a couple of minutes. Work this out and send me the answers, please. No, the answers are not correct yet. Uh, None of you have got the correct acceleration yet. Please solve the equations more carefully. Okay, let's understand this question fully. So you can see that same amount of tension will be acting at all the points, okay, because the thread is massless, and this one has a weight which is equal to how much? 60 newtons. This one has a weight which is equal to 40 newtons. So A will dominate. So because A's mass is more, so that means A will be accelerating downwards and B will be accelerating upwards. But they will have the same magnitude of acceleration. Why? Because the thread is inextensible. Okay. Yes. Finally, Kunj, your answer is correct. Okay. But tension you have to check once. Tension is probably not correct for you. So you will get the common acceleration magnitude as 2 meters per second square when you solve. Okay. Or G by 5. And you should be getting the tension as 48 newtons. Yes, that's correct, Kunj. 48 newtons is correct. Okay, so let's understand how this is coming. So you have to make the free body diagrams. So A's free body diagram, tension, weight, and downward acceleration. So when we write net force is equal to mass into acceleration, we'll write net force in the downward direction because weight is dominating. Okay, so this will become 60 minus T is equal to 6A. So this is our equation 1. Okay. There are no horizontal forces, so we'll get only one. This is A's free body diagram. Now B's free body diagram, but which force is dominating? Tension is dominating. Okay. So the acceleration is upward. So for this we have tension minus weight, that is the net upward force, is equal to mass into acceleration. So T minus 40 is equal to 4A. This becomes our second equation because we are substituting the mass of B as 4 kg, substituting the mass of A as 6 kg. Okay. Then the next thing is you have to solve these two equations. So just add the two equations. Equation 1 plus 2 kar do. So you will get 60 minus 40 is equal to 6 plus 4A. So from this you will get the acceleration as 2 meters per second square. And then substitute this in 1 or 2, whichever. You will get tension as 48 newtons. Okay, same process as previous question. Difference is there. One block was moving horizontally. Here both the blocks are moving vertically, but one is moving downwards. The heavier one is coming downwards. The lighter one is going upwards. Okay, so now let's come to some of the questions from worksheet 1 or assignment 1. So hope this is clear to all of you. Good. Now we will discuss assignment 1 doubts. Does anyone have doubt in the first two questions? Does anyone have a doubt in question number one or two? Question one, Hitanshu. Okay, let's see. So, very simple question. It says that an object experiences an acceleration of 4 meters per second square when a certain force F naught acts on it. Okay. So, in question one, the information that is given to us in this E is equal to 4 meters per second square. So, we can say that F naught is equal to 4m. This is the first information that we have. Okay. Then, what is the acceleration when the force is doubled? So, if F is equal to 2F naught, so what about the acceleration? It will become, let's say, it will become A2. So A2 will become F2 divided by the same mass. So here you can see that E is equal to F naught divided by m. So this will become 2 times F naught by m. And this is equal to 4 meters per second square. So this will become 8 meters per second square. Okay. So that is the first part. Now second part, a second object experiences an acceleration of 8 under the same. So now let's say the second object, its mass is m2. Okay, उसका मास अगर m2 है, so f naught is equal to m2 into some acceleration a prime, and this acceleration a prime, assignment 1 which I have sent of Newton's laws of motion. There's only one assignment I've sent so far in Newton's laws of motion, so that one. So this is given as 8 meters per second square. So compare this equation with this equation. Okay, so you will see that m2 will work out to be half of m. This one has a mass which is half because the same force is giving you double the acceleration. So now third part what is happening is that the two objects are tied together. So this object M and this object M2, they are tied together, and you are applying the same force F naught. So now you have to find how much acceleration the system will have, what acceleration it will produce. So this acceleration, let's say A double prime, this acceleration will be the force divided by the combined mass. So that is how much it will be, F naught divided by M plus M by 2. So F naught divided by 3 by 2 m, or 2 by 3 F naught by m. Now from here you can see F naught by m was how much? 4. So what will this acceleration be? So this acceleration A double prime will be 2 by 3 of 4, or 8 by 3 meters per second square. 2.67. Okay, is this clear? Om and Hitanshu, this question is clear? Okay, right. Anybody has a doubt in the second question? Okay. So second question, I'll just give you an idea of how to do it. See, in the second question, it is given to you that F naught by m is equal to, how much is it? 5 meters per second square. This is given. Okay. Now, for example, the A part, what you're doing is you're applying two forces of F naught like this. Although it's a three-dimensional situation, so you place this block on this surface, but you are applying these two forces parallel to the surface and at an angle of 90 degrees. Okay. So what is the net force becoming? The net force is becoming their vector sum, which is this. So here, so it will have an acceleration in this direction. So in this case, the acceleration will be that net force divided by the mass. So that net force in this case will become how much? F naught root 2. Why? Because the two forces you are applying were of same magnitude and they were at 90 degrees. So you can see that. Okay. So hope this part is clear. Okay. Two equal forces, equal magnitude forces at 90 degrees, the resultant will become how much? It will become square root of F naught square plus F naught square, because the theta is 90 degrees, like this. Okay. Now likewise in the B part, what is happening is you are applying forces which are at 45 degrees to each other. So ये वाला force ऐसा है, and secondly ये force different है, it is 2 F naught. Okay, and the angle is 45 degrees. So इनका जो resultant force होगा वो कैसा होगा? It will be something like this. This will be the net force. Okay, so this net force how we'll calculate? You can use triangle law. So it will be a square, that is 2 F naught square, plus b square plus 2ab into cos of the angle between them. So that is 45 degrees. So use this formula. So this will become F naught 4 plus 1 plus 2 root 2. That will become F naught into 5 plus 2 root 2. Now you do some calculation work. Okay, take root 2 as approximately 1.4. So this becomes approximately F naught into 5 plus 2.8, or F naught into square root of 7.8, which will further become approximately 7.8 का square root will be approximately 2.79 or 2.8. So approximately 2.8 F naught. Okay. So the acceleration will be this net force divided by mass. So that will be 2.8 F naught divided by m. So that is approximately 2.8 into 5. Okay. So that is close to about 14 meters per second. Okay. So whichever is the case, whether it's a calculation mistake or wrong steps, make sure you understood this now. Okay, now third and fourth are I think easy questions. Now just use kinematics. Example, in third question, you just use acceleration is change in velocity upon change in time. Okay, so use this and use F is equal to ma. So in third one, the velocity is changing by a factor of 10 meters per second every 2 seconds. So you can see that the acceleration is 5 meters per second square. And then substitute this in this equation and you will get the answer. Similarly, in the fourth one, is given that it travels a displacement of 18 meters in time 6 seconds. Is it? So you find the acceleration using this relation, that initial velocity was 0. So s is equal to half at square. So substitute these two things here. Okay, that 18 is equal to half a into 6 square. So from this you get the acceleration, and then you use F is equal to ma again. So these are basic questions on this. Okay. Now what about fifth question? Anybody has a doubt in that? Question number 5, no. Okay, very good. Sixth is very easier to just convert. What about seventh question? Seventh question is also about substitution. Yeah, Rishi, I got it. You are clear till 10th. I'm just clearing the doubts for others. Okay. So let us come to 10th question then. Anybody has a doubt before question number 10? Please let me know. Question number 8, Ruk sir. Okay, we'll discuss. Okay, 8th and 9th we'll discuss both. So देखो 8th में क्या हो रहा है? This is similar to the question we were doing last time in class. There are two blocks against each other on the smooth surface, and we are applying a force like this on them. And let's say this is A and this is B. So mass of A is given to us as 2 kilograms. Mass of B is given to us as 1 kg, and the force we are applying is given to us as 5 newtons. Okay. Okay. So first of all, we have to find out what is the acceleration of the system. Then we have to find out the, okay, so that's fine. What is the acceleration of 1 kg block? Okay, that will be the same. What force is exerted on it, and what is the origin of the force? Show all the forces acting on the 2 kg body. What is the net force acting? Okay, so basically what you do is now you make the FBDs of each of the blocks. For the block A, what all forces are acting? There's F from this side, but some kind of normal force from this side. The ground will apply some normal reaction, and there will be the weight of this. Okay, and it has an acceleration A like this. So we have F minus N is equal to mass into acceleration. So this equation becomes 5 newtons minus some normal reaction is 2 kg into acceleration. And vertically, this normal reaction is balancing the weight. So the normal reaction acting on it is equal to the weight, equal to 20 newtons. Now similarly, you look at the free body diagram of the block B, and there's only one horizontal force acting on it, that is this normal reaction. And it also has the same acceleration. So for B, we have the equation N is equal to mass into acceleration, or that means that N is equal to 1 into E. So that is our second equation. Whereas normal reaction from the floor is balancing the weight, which will be 10 newtons. So now solve equation 1 and 2. So you will get the acceleration as 5 by 3 meters per second square, and you will get the normal reaction as 5 by 3 newtons, because the mass is 1 kg. Okay, so that gives you the acceleration. Now the net force acting on B. So let's look at the language of the second part. Okay. What is the acceleration of the 1 kg block? So obviously that is 5 by 3. Okay. What is the force exerted on it? So this thing, the force exerted on B. What this means is the force exerted by A on B. So that is nothing but N equal to 5 by 3 newtons. Okay. And what type of force this is? This is a normal reaction force. So this is a contact force between the blocks. So what is the origin of contact force? It is always intermolecular force, which is electrostatic in nature. Okay, any sort of contact force comes as a result of the interaction between molecules, and that is electromagnetic in nature. Okay. Whereas the 2 kg block, the net force on block A, that is nothing but F minus N. That is the net force. And that is equal to what? Mass of A into acceleration. So that is equal to, so whether you write it like this, that it is 5 minus 5 by 3 Okay, or you can write it as mass into acceleration, so that mass was 2 kg into 5 by 3. So the net force acting on this block is 10 by 3 or 3.33 newtons. Okay, so hope this is clear. Okay, good. So let's come to ninth question, ninth and 10th. So question 9 is again you have to solve for net force. So to do the vector addition of these two forces, F1 is given to us as 20 newtons, F2 is given to us, but the direction of F2 is like this, that this is 30 degrees, okay, and this is 90 degrees. So the total angle between these two, ये कितना है? This theta is 120 degrees, okay, and F2 is like this, it's 20 newtons. So the net force is the vector sum of F1 plus F2. Okay. So the magnitude of the net force will become like this. So just use this and you'll get the answer. Okay, so in that substitute, magnitude of F1 is equal to F2 is 20 newtons and theta is 120 degrees. So when you do that, you will get the net force to be 20 newtons. So from that you will get the acceleration. Hitanchu, this is clear, beta? Is this clear, Hitanshu? Okay, Hitanshu, okay, good. Okay. So net force only you have to calculate, triangle law you are using. Okay, let's come to 10th question. So 10th question is the similar thing, but instead of diagram given to you, the vectors are given in component algebra, right? So what we have to do in 10th question is that you have to calculate the net force by doing the addition of the vectors. Okay, but for that you have to use the component algebra for the addition of the vectors. So the two forces acting on the body, they are given to us as, so mass of the body is firstly given as 2 kg. Okay. F1 is given to us in vector form as 2 I cap minus 3 j cap, and the second force is given to us in vector form as 4 I cap plus 11 j cap. Okay, and these are both in newtons. So initially the object is at rest. Okay, so you have to find acceleration, velocity, all these things. Where is the object after 3 seconds? All that. So what you do is you calculate the net force. Okay, so you can see that net force is 6 I cap plus 8 j cap. So you can understand that this net force is like this. It has a magnitude of 10 newtons, okay, and it is acting with respect to the x-axis. It is acting at an angle of 53 degrees. So that will give the body an acceleration in the same direction. So the acceleration will be what? It will be net force divided by mass. So if you write the acceleration in vector form, you have to divide this in newtons divided by the mass, which is 2 kgs or 4 kgs. 4 kgs, sorry. This is 4 kgs. So divide this by 4. So 3 by 2 I cap plus 2 j cap in meters per second square. Or if you want the magnitude of the acceleration, it is the magnitude of the net force divided by mass. So that will become 2.5 meters per second square. So once you got the acceleration, you can find out velocity as acceleration into time, or speed as magnitude of acceleration into time. You can find the displacement as half at square in vector form, or its magnitude you can find as this. So just use these relations. Okay, so Rishi, hope this question is clear. Okay, so people will conclude the session here today. The remaining five questions you try out yourself based on the examples we've done in class today. You should not find it too difficult. Plus, I'll be sending you another assignment along with the notes and everything. So that's it for today's session. Make sure you revise today's session very carefully before you set out to do the next set of questions. You can also start doing questions from H.C. Verma, Newton's laws of motion chapter. Okay, you will see there are a lot of questions based on pulley systems and systems with normal reaction, etc. So you can start doing the questions from the exercise.